Everybody, welcome back to another fun and exciting Algebra 1 class. Today we are going to be jumping into Lesson 7.4. Lesson 7.4 is found on page 237, so go ahead and open up your books to page 237. One of the hardest parts about the factoring chapter, in my opinion, is the different types of factoring problems that we have. So one thing that you need to be careful of as we're going through these different lessons is kind of categorizing them and saying, okay, lesson 7.4, it's different than lesson 7.3. It's different than lesson 7.5 is going to be. It's different than 7.6. Each one of these is its own separate problem. Although they are all factoring problems and they all solve kind of the same way, you have to do what's called identify. You have to say, okay, which one am I working on? So as we go through this lesson, make sure that you're kind of trying to, in your mind, identify, okay, what are some of the characteristics that are unique to this lesson? What makes this lesson different than last lesson? Because that's going to be very important by the end, because we're going to have 5 or 6 different ways of factoring. And so you need to make sure that you know what the characteristics are of each different factoring problem as we're going through it. Okay, so difference of two squares, page 237. I wrote this down here. Don't forget to look for common factors first, every time. It doesn't matter the type of factoring problem that we're dealing with. It doesn't matter if we're dealing with perfect square trinomials, the difference of two squares. Later, we're going to get into what's called quadratics. Some of you are like, quadratics? Ooh, that sounds hard. It's not really that bad, okay? But we're going to get into different types of factoring problems. When we get into those, you have to remember something. This is where you start every single time. You always look for common factors. And I promise you, I can promise you, because I've been doing this long enough, I know that this will happen. I'll tell you this, and then we're going to get on to the quiz, or we're going to get on to the test, and you're going to miss it because you forget to do this. I promise. I promise. Okay? I know more than one of you. I promise you that. I know. I've been doing it for a long time. You will forget to do this. I would love for this to be the first time nobody in a class ever forgets to common factor, but it's not going to happen. Somebody's going to forget to common factor. Please don't be the one to do that. Always first do your common factors. Then you go on to the next level, you go on to the next step. Okay? All right, but as we're going on to that next step, let's think about something. Do we remember what conjugates are? This was from last chapter. Hopefully you do. A conjugate is something that looks like this. X plus 1, x minus 1. Okay? In this factoring chapter, this factoring lesson, 7.4, your answer is always in this lesson 7.4, your answer is always going to be a conjugate. This is the only answer you can get. Now, sometimes if we have a common factor, if we have one of these first, we might have something else. Like we might have a 3 that factors out, for example. So you may have something else in front of it, but your main answer in this lesson is always, I promise you, it's always going to be a conjugate. Okay? There's a reason for that. Look at what we're dealing with. We're dealing with the difference of two squares. Let's go ahead and just jump right into one, and then I'm going to go and we'll look at the steps of how to do it. This is what's called a difference of two squares. Let's talk through that. What is this? Well, that's a perfect square. What's the perfect square of that? 2x. Because if you take 2x times 2x, you're going to get 4x squared. Okay, so that's a perfect square. Now look at this. That is also a perfect square. What is the answer to the square root of 25? Well, it's 5. 5 times 5 equals 25. Now look at this sign in the middle. That is the difference. That is a subtraction sign. So look at what we have. The difference of two squares. So look at our example right here. The difference, that's this, of two squares. That's a square, and that's a square. All right, so how are we going to solve this? How are we going to solve this? I'm going to leave this right here for a second because we're going to come back to that because that's the first step. All right, first, here we go. How to identify the difference of two squares. The first and second term are perfect squares. So there we go, first and second term. So how do we solve this? We square root the first and second terms. So take this. There is no middle term. That's the second way to identify this. There is no middle term. And then the third, the middle sign is negative. The middle sign is negative. And look, there's the middle sign is negative. Now, how do we solve this? All right, so let's look at how to actually factor these. So we know how to identify them. We know what they look like now. Well, the steps to solving the difference of two squares is really just two steps. Number one, take the square root of the first and second term. So we're going to square root the first term, square root the second term. Then we're going to turn them into conjugates. We're going to have one positive and one negative. Okay? So, two steps. Square root, first and second terms. Step number two, turn it into a conjugate. All right, let's take a look back at our problem that we were working on right here. So 4x squared minus 25 gives you, so if we take the square root, so if we take the square root, we get 2x. And if we take the square root, we get 5. So that's step number one, take the square root of those. Now what do? We turn it into a conjugate. So we're going to make one the positive, and we're going to make the other the negative. So we're just going to make a conjugate. 2x plus 5, 2x minus 5. Done. Circle that answer. That's your answer. Okay? Let's do another one. That was so fun, right? Might as well do another one. All right, so here we go. We can actually solve this one a couple different ways. This one's interesting. So let's actually solve this a couple different ways. The first step I said was always looking for a common factor. Well, look what I see. I see a common factor in there, right? What's common? Well, the 9 is common. So we can take out the 9. What else is common? That's it. Okay, nothing else common. And so the 9 comes outside, and we're left with x squared minus 4y squared. Now, we're not done yet. Why not? Because we actually have perfect squares right here. Look at those perfect squares. So if we square root, and difference, notice that we have the difference of two squares. So we have our 9 outside still because we already that was our common factor. We factored that out. And now we have x because we factored this. Step one is factor the first one and then factor this. 2y square root. And then what do? Step number 2 was we make a conjugate out of this. So we have a plus 1 and we have a minus 1. So it's the same. X, 2y, plus minus. We just turned it into a conjugate. And we're done. That is our final answer right there. Now, I said that you could do it two ways. Now, this one is like a tricky one. This one is one of the very few, and I don't even really want to show you this, to be honest, but this is one of the few that you'll ever get that you can get away with it if you don't take out the common factor first. And there's a reason why that is. Look, this one is already a perfect square. What's the perfect square of that? 3x. What's the perfect square of this? 6y. Okay. Now, it is a little bit tricky here. This one gets really tricky really fast if you don't common factor. I told you should common factor first. Okay? But if I make my conjugate 1 plus and 1 minus, I have a problem still. What's my problem? My problem is that I can still take out common factors from this, can I? From both of them. I can take out a common 3 here, and I can take out a common 3 here. Now look what happens if I do. I took a 3 out. I actually have to multiply that 3 together because they both came outside. So there's my 9. That's where my 9 comes from. And look what I'm left with. So I divide by 3, and I'm left with my x plus 2y, x minus 2y. That one's pretty tricky. You've got to take the common factor out sometime, and that one's a tricky one where you could do it at the beginning or at the end. I'm telling you, it's worse if you do it at the end. My suggestion is to always take out common factors at the beginning. That will save you much pain and much heartache. Trust me. Let's try this one. All right, let's identify it. What are we looking at? Well, that's a square. This is a square. Now, let me tell you something about, we haven't really talked about this yet. Every single even exponent is a perfect square. Because look, a cubed times a cubed equals a to the 6th. That is the same as that. Every single even exponent is a perfect square. What do I mean by that? 12. 12 is a perfect square. A to the 12th. What does that equal? A to the 6th times a to the 6th. Okay? So every even one is not. It's what's called prime. Because look, 7, a to the 7. Well, it's not necessarily prime, but it's prime as far as square factoring goes. Because this would equal like a cubed times a to the 4th. That would give us a to the 7th. But these are not the same, so we can't square root that. It's not square rootable. It's not a perfect root. Okay? But every single even exponent is a perfect root. So look, perfect root, perfect root, perfect root, difference. Guess what we have? We have the difference of 2 squares. So what do we need to do with this? We need to square root this, and then turn it into a conjugate. So what is the square root of 16? 4. What is the square root of a to the 6th? A cubed. A cubed times a cubed equals a to the 6th. And then b to the 4th is b squared, because b squared times b squared equals b to the 4th. And then we will square root this, and we will get c. Now we're going to turn it into a conjugate, so that means we're going to have one positive, and then we're going to write the same thing, a cubed b squared minus c. There's our conjugate, plus, minus. Okay? So just follow your steps. Identify it. Is this a perfect square? Yes. Is this a difference? Yes. Is this a perfect square? Yes. Then we have the difference of 2 squares. Let's do one more. So here we go. We have a perfect square, a difference, and a perfect square. So just do it. Square root that. X squared times x squared equals that. Square root that. 1 times 1 equals 1. And then turn it into a conjugate. We have a positive 1, and we have a negative 1. Now, we're not done yet. This is the tricky one, okay? This is one where you have to sometimes say, oh, wait a second, there's more. Because look at what I have now. One of my factors, I have a perfect square, a difference, and a perfect square. What do we have right here? We have another difference of 2 squares. Sometimes when you factor difference of 2 squares, you get another difference of 2 squares. So what do we have to do here? We have to do the same thing. Square root x, square root 1. Our sign makes it a conjugate, positive, negative. So there's our answer. This is part of our answer. This is part of our answer, and this is part of our answer. So never stop until you can't go any farther. And right now, some of you are thinking, but wait a second, what about this one? What about that one? That is not a difference of two squares. Because look, I have a square and I have a square, but that is not a difference. That is an addition sign. So that means that that is what's called prime. I can't factor that one. Because if I try to factor that one, it would give us something else. It's going to give us a middle term, in other words. Why don't the conjugates give us a middle term? Well, you had to remember back to the chapter where we did the conjugates. So let me show you these conjugates real quick, and then we'll be done. So x plus 1, x minus 1. Don't forget when we FOIL this, and let me FOIL it with a different color so you can see it. That gives us x squared. The outers gives us negative x. The inners gives us positive x. And then the last gives us negative 1. Notice that these cancel with conjugates. So what are we left with? X squared minus 1. Okay, that's where we were up here. So when you FOIL conjugates, you don't get the middle term. But if I FOIL this, for example, if I try to factor it, let's say I try to factor it x plus 1, x plus 1. Well, that's not going to give us this. That's going to give us something with, that's actually going to give us 2x plus, x squared plus 2x plus 1. And so that did not give us the same thing. So that, you can't do that. Okay? So this is wrong. You can't factor this. This is your final answer right here. So you'd circle that. This is your answer, and this is your answer. Okay? Hopefully I didn't confuse you too much there. The big thing is just following the steps. What are the steps? They're right here. Number 1, square root the first and second terms. Step 2, turn them into conjugates. One gets a positive sign, one gets a negative sign. Done. Unless you might be able to factor it more. And sometimes you can. If you can factor it again, factor it again. Please don't forget to take out your common factors. That's going to be the biggest thing that you need to know. All right? Well, that's everything I have for you in this lesson. I hope you learned something. We'll see you later. Bye-bye.